Welcome back to Maths with Mrs. J. I now want to talk to you about function notation. Up to about year 10 level, normally if you're talking about graphing a function or you're talking about values of a function, you'll talk about it in terms of y equals 2x minus 3 or y equals x squared plus 5 or something like that. You talk in terms of y. From now on, quite often, we're going to use function notation. Now, for all intents and purposes, f of x basically means your y value. The great thing about this is that built in to your expression here, you've got what particular x value you're talking about. So instead of having to say when x is 3, what is the y value, you can just say what is f of 3. This is a substitution exercise. It's also very handy when you get up to differentiating, which will be later in year 11 for most of you, and we want to do the derivative of f of x, we can just do f dash x, saves having to write dy dx and all that sort of stuff. If you want to write the inverse function, you can write f inverse of x. It just saves a lot of messing around as far as your terminology and your setting out is concerned. Basically, all we do here is wherever we see an x, we're going to sub in whatever this value is. So if we want f of 3, we're going to get 4 times 3 minus 7, which is 12 minus 7, which is 5. F of negative 1, wherever we see an x, we're going to sub in negative 1. So 4 times negative 1 minus 7, which is negative 11. Have a look at this example here, same sort of thing. It doesn't have to be an f of x, it could be g of x, h of x, p of x, whatever you want to call it, okay? G of 0 means sub in, wherever we see an x, we're going to sub in a 0. So 0 squared minus 3 times 0, which of course is 0. 3 quarters squared minus 3 times 3 quarters. If we fiddle around with our fractions a bit there, we're going to end up with 9 on 16 minus 9 on 4, and you'll end up with negative 27 on 16. You can leave it as an improper fraction or change it to a mixed number. It's up to you. Be careful with negatives here. We're squaring our x. So when we set this out, our substitution step, we need to put brackets around our negative 2. Why do we need to do that? Well, negative 2 squared is not the same as negative 2 squared. And this is the one that we want. Because it's the x that's squared and x is negative 2, we need negative 2 by negative 2, which is positive 4, right? If you write it like that, that means square it and then make it negative, which is a different thing. That gives you negative 4, that gives you positive 4. Now, a lot of people will write negative 2 squared and then in the next line they'll write 4. That's still not good mathematical communication, all right? You should have brackets around it. Okay, let's just go on to question 3. Again, it's really just a substitution exercise. So all we're doing is wherever we see an x, we're putting in a half. So what we're going to get here is h of a half is going to be a half squared plus 8 divided by a half. What are we going to get? 8 1/4, which is, okay, so we're going to get 33 on 4 divided by a half, which is 33 on 2, which is 16 and a half. This one here, same sort of thing as normal, but we're solving an equation. So we don't know what the x value is, but we do know what the function is. All we're doing is we're subbing in and we're going to solve a very simple linear equation. Take your 6 away from both sides, divide both sides by 6, simplify down. You can leave it as an improper fraction or you can change it to a mixed number. It really doesn't matter. Okay, now we're going to be working with our function notation over our next few videos where we talk about functions of functions. We're going to talk about piecewise functions, and we're also going to talk about inverse functions.